Dr. Penny, we can't solve the problem. The table lists sulfuric acid in aqueous solution and sodium hydroxide in aqueous solution and liquid water, but it doesn't say anything about sodium sulfate. We can't solve the problem. Well, yes, you can. Yes, the table doesn't give a listing for sodium sulfate in aqueous solution. But what do you get when you put sodium sulfate in solution? What you obviously get is you get sodium ions and sulfate ions. And both of those are listed. This is something you have to keep in mind about ionic compounds. In solution, they're going to be in the form of ions. I have to look up the delta H's and zeros and the delta S zeros for the ions in solution. The table is not necessarily going to list the compounds in solution. So now you have enough information to go get the delta G, which is minus 159 kilojoules. Dr. Penny, that's not the answer I got. Well, for example, maybe you didn't remember to balance the equation for everything. One of the things you will notice is that the sulfuric acid in aqueous solution has the same value as just sulfate in solution. That's, of course, because we said when we're talking about solution, we reset the delta H and the delta S scales, and 1 molar protons in solution simply has a heat of formation and an entropy of 0. So the sulfuric acid has the same values as just the sulfate in solution. And this is going to be true for any of the strong acids. The acid and its ion are going to have the same values since the protons have 0, delta H and delta S. And that concludes our lecture for thermodynamics for today. See you on Wednesday.